it's just you and I. We're going to do questions with just Mark. Pull up a pew. Let's make this social. You've got a chair there. So, show Gizmo, or just yell questions at me, this digital thing, just yell at me. Right, where do we even start? I'm gonna start kicking us off with the challenge that you seem to have, and you see it in the screwed up faces of people who, when you talk about an artificial meat or a lab-grown meat, is ew, or you called it the yuck factor. It seems like you get that because you're trying to replicate something that people already know versus trying to create a market of something that doesn't exist. So do you think there's a strategy from a business point of view of actually saying, do you know what, we know what meat is, and we know that beef comes from cows, and that's one thing. Here is a meat-like product, like dairy-free creamer. I don't know what's in dairy-free creamer. It tastes great. I'm fine with that. And actually, rather than try and make people relate something to a current product that they know, bringing a whole new product that people can't say yuck about because it's not trying to be anything that currently exists.
Right. But on the other hand, we can adapt to things that currently don't exist and that we gradually learn to eat. There are many examples in the past. The fact that there is a product already there that is being perceived as natural, being perceived as healthy, and is definitely tasteful and relatively cheap is going to be an extra hurdle. But on the other hand, it's very easy to make people understand that there are consequences with the current production of that particular product, which they're also concerned about. So I think that's something that is sort of the driver for people actually to think about this and to maybe rationally want to accept it, but they still have to emotionally accept it.
So perhaps it's a generation thing. So kids growing up who haven't not known a life without it.
It's definitely a generation thing. If I talk about this subject to people under the age of 25, it doesn't seem to bother them at all. If I talk to this with kids below the age of 10, they start to fantasize about all the possibilities, and it's really amazing.
Yeah. Okay, so I'm going to do a non-digital survey. Hands up if you would eat Petri dish grown burgers. Hands up if you'd like to, because I quite like to try it, and I was a little bit disappointed that Mark didn't bring any, and apparently Math wasn't impressed. Hands up if you wouldn't touch this in a million years because it's weird and it's just a bit freaky, and so everybody's in. One, two. Okay, so there's a couple who are like, actually, no way. But the majority of you seem open to, and so I guess it's that sort of trialing it out. Now, we have a room full of ag people, some of which will have farms, some of which will have cows, and there's a whole industry that New Zealand is based on, which is our biggest export, based on cows and large land mass and that traditional sector. Do you think that target market should be worried, or do you see it being something that's worked alongside, and almost as we're going back to that rich-poor divide, and that those who can afford to pay for the land and are not that bothered about the environmental consequences as maybe that's going to be their market, and then there'll be the lower end market for the meat-like product that potentially could be cheaper?
I don't think so. I think we cannot have that division. The initial question, I guess, was should you be worried? It's not going to happen overnight. Is it something that you need to think about? Yes, I think it is. Because I think it will have appeal and it will have a lot of potential. And if it does, then you better start to think about it now, how it's going to affect your business than, let's say, 10 years from now. Whether in the next 20 years or so, there will be definitely a sort of diversification of products, and there will definitely remain a market for, even in my most optimistic views, there will be a market for livestock, artisanal, traditional meat. I don't think that in the long run, the two can coexist. And my PR people tell me not to tell this story, but I do believe in it. And one of the, so I have this analogy, and you may think about what it's you are to judge. I have this analogy with eggs, with free-range eggs and battery hen-laid eggs, or caged eggs. So in the EU, as probably some of you know, caged eggs are now forbidden. You can no longer buy them, you can no longer sell them, except for in processed food. And that's solely on the basis of animal welfare. So it was consumer driven. At some point in the supermarket, you couldn't get any caged eggs anymore, or there were very, very few. So it was consumer driven, and it was based on animal welfare alone. And as I mentioned, I'm a physiologist, I do animal experiments, and I'm as sensitive as you are to the public opinion towards animal welfare. And that's why I think in the long run, if you have a product that is essentially the same, without the animal welfare connotations, whatever you think of it, it will gradually phase out the traditional meat. That's what I think.
Anybody quaking in their boots yet? Okay, so let's talk money. I mean, this industry is about making profit, the food industry, and so you've talked about the price point being 65 a kilo, whatever. Look, that's a short-term thing. What is restricting price right now? And let's say 5 years from now, once the technology has increased a little bit and production processes are a bit more efficient, where do you see that price point being? And what do you think how low can we go, basically?
Right. So given that this is more resource efficient, and yet, yes, the technology right now is still not very efficient, but can be made efficient, then in my mind the price has to come down and has to be at least competitive with current beef price or future beef price, or even lower than that. It could be even lower than that. And if that happens, then you can imagine.
And so it's a batch process right now.
Yeah.
How long does that, from stem cell through to final product, how long is that process? And sort of how restricted can you be? So what sort of areas of lab space would you need to make, I mean, you can give me the numbers, but let's say 100 burgers versus... Right.
So the time from stem cell to hamburger is 7 weeks. That's for one hamburger. That's the same for 50,000 hamburgers. It depends on your capacity of growth. That time cannot be changed. It depends on the multiplication time of cells, of mammalian cells, which is sort of fixed, and you don't want to mess with that. The example that I showed of the 25,000 liter bioreactor, which is basically half a size Olympic swimming pool, feeds 10,000 people. So for Auckland, you would have, I was told, about 1 million people. You would have 100 of these, or 50 of these Olympic-size swimming pools to feed the entire population.
So let's go back to, we had the 3D printing. We can 3D print our own food at home potentially. Could I, potentially, 10 years from now, because I grow cells in my lab at work, could I not just have a little incubator set at 37 degrees? You mail me some dehydrated stem cells, I rehydrate them, and then we all just have a part of our kitchen where we grow our own protein product. Is that a possibility?
Yes, that's a possibility, and that would even give more control over how your food is being produced. You have to know 7 weeks in advance what you want to eat, which is a minor detail maybe. And it's not really a practical sort of proposition because, you know, we had in the Netherlands, we had this fad of giving fathers on Father Day a bread maker. That was very popular for about half a year, and then they all ended up in the attic collecting dust. And baking bread is much, much easier than making meat in your kitchen.
Yeah. Yes, but I don't save money on baking my own. I have a bread maker. It's in the attic, right, gathering dust.
Right.
And it wasn't cost efficient for me. It was just fun to make bread. But you're talking about the potential for this to be a cost efficient. I mean, protein is relatively expensive as a food source, as we talked about. So you're talking about this potentially with a small investment of an incubator and a couple of raw materials to potentially bring that cost down. And then it's not, 7 weeks is a long time to think about it, but then it's not comparable to the bread maker, right? It's actually about how do you feed a family of 4 at a lower price with nutrients.
Right. But still, if you scale it up a little bit to that 25,000 liter, you can gain even a much higher efficiency. So I think the story of Pookie is a much more realistic story. Still romantic, but more realistic.
So I've seen some questions coming up on the feed here. One question is, you've got to feed the cells something. So what are you feeding the cells?
Right now we are feeding them commercial fluids consisting of plant-based sugars, amino acids, and vitamins and minerals.
Good to know they're vegetarian.
Right. The cells are vegetarian, yes. And we have played a little bit with algae proteins and algae sugars, so we are very versatile in what we feed them. The eventual question, obviously, is going to be what's the conversion ratio of these cells. And we think it can be about 2 instead of 7 in a cow.
Other questions? Can you do fish and other types of
Yeah, no problem. Yeah, actually, other people are working on fish. Scandinavian lab started on fish about 7 years ago. A lab in Israel is working on chicken. For all these, we have sort of focused on beef because of the food security and the environmental aspects. But people who are more concerned about animal welfare are focusing, for instance, on chicken because there are many more animals involved.
Question from Sarah. Can you make it into a tasty steak or just a hamburger-looking thing?
Right. That's an important question. The technology that we're using right now relies on self-assembly of the cells. And there's a limit to that. There's a limit to the size of the tissue that it can make because oxygen and nutrients have to diffuse into the tissue. And so if that tissue becomes too thick, the center will die because it doesn't have sufficient oxygen and nutrients. So that's why you and I have blood vessels. Now, making blood vessels happens to be my bigger hobby. That can be covered, which also for medical tissue engineering obviously is very important. Having said that, although I would love to make blood vessels and make a bigger steak, I actually think that I just need to have a channel system that would allow me to perfuse the medium together with the oxygen and the nutrients to every nook and cranny of the tissue so that you can make this bigger steak. And it's absolutely required that we do that. It's a slightly more difficult technology, but it's there and we can use it to make a steak at some point.
Okay, so the limitations right now are either vascularization of a tissue, which is quite hard to do, but they're working on that in the 3D printing of tissues industry right now, because that's the biggest problem. The reason why you can't 3D print organs right now is lack of vascularization. So there's 2 communities, I guess, working on a similar issue, but from different aspects.
Right.
Or changing the way that we diffuse oxygen through thickness of substrates, right? And then there may be a microfluidics argument of actually how we could create nanochannels or microchannels to do that. So it just seems like a really small jump that we need to find to create. I say
hopefully,
that obviously.
Yes.
It seems easy from here, sitting here, being like, oh yeah. So there's potential for this to. I mean, because you guys really at the early stage here, I think, in this whole field of tissue technology, and so 5 years from now, do you think there's going to be are you seeing lots of big changes in the field or big discoveries?
Well, there are a lot of people are working on the vascularization, so they're making the blood vessels in tissues or a channel system. Most are working on blood vessels because of the medical applications. Yes, there are, every week you see another advance in the technology that allows you to do this. The question, but this is very technical, whether you want to make blood vessels or channels is a very technical thing, and we are working on the assumption that there's not a lot of interaction between the vascular cells and the muscle cells. But we don't know that. So we are sort of betting on both horses and trying to also figure out whether the blood vessels are actually necessary.
So I'm going to steal the last question, if that's okay. And that is, I'm thinking of competitive advantage, right? So if you're going to buy this meat-like product, there's got to be a competitive advantage. And we have a real food wastage problem and a food spoilage problem, especially with meats that need to be refrigerated because of bacterial contamination. Do you see a potential to be able to engineer in with an in vitro tissue type an antibacterial component to mean that live meat-like product could actually spoil less or not host certain bacteria that we have with current types of natural meat?
Right. Well, the production system by definition is sterile, is bacteria-free. Otherwise, you wouldn't be able to do it. So we have no contamination when we start to store our product. So that's one sort of advantage. Obviously, we don't know how that's going to affect aging of the tissue and stuff like that. We need to investigate that. The other advantage, which I haven't talked about, is that it creates a lot of other possibilities. I mentioned that we are making this fat tissue. And this fat tissue, as probably some of you know, is perfectly capable of making omega-3 fatty acids that lower your cholesterol. They just don't do it, at least not to the extent that we want it. But we have these cells under control. We can coerce them to make omega-3 fatty acids. Hopefully it doesn't start to taste like fish. But we can do that. So we potentially can make a healthier product, which would be a major competitive advantage, I think.
I could talk to Mark all day, as I'm sure you could listen to him all day. For those of you who want more of Mark, he was interviewed by Kim Hill over the weekend. You can listen to that. It was a great interview. She's really good. Online, it's available. I'm afraid the thing's flashing, so we're out of time, sadly, because I could do a whole day of this. But ladies and gentlemen, please put your hands together and thank Professor Mark Jones.